So hi, my name is Johan Sommerfeld. Today I'm going to present a small library or framework called Pyrlang, which connects Python and Erlang. So, as I said, my name is Johan Sommerfeld. I'm a Master of Science in Electrical Engineering. I've been working with computers since roughly '98. Founded my own company at 2010 as a consultant, and I've been working at Sigicom in parallel since 2012. They were my main customer, and since last year I'm also hired, so I'm now a regular employee again. So Python and Erlang, they're both quite similar, but also different. So for me, they both have a solid foundation for operations. They're really well suited for running it in production. Other languages might be better in terms of development speed and things like that, but I think that Python and Erlang is both easy to develop and also especially really easy to operate in production environments. Python is both object-oriented, but you can actually apply quite a lot of functional programming with it if you want to. It's just that it has side effects since you have mutable states and things like that. Where the difference comes in is that Erlang is extremely much well-suited for concurrency. String handling and things like that, Python does better than Erlang. Also, the community is bigger or different in Python. You have a lot of academia within the Python community. So what drove me to the idea of Pyrlang? So when I started working with Sigicom, I was responsible for developing Infranet, the new cloud platform of Infranet, which is basically their central central system for data harvesting. So Sigicom builds sensors or devices, embedded devices, that collects data and then sends it to a central point. And that was supposed to be redone, and so I came in, and it was a whole thing. So it was data harvest, and then we fetch data in extremely different ways. So we can't really pre-calculate something so it's easy to get. So we fetch a lot of data, and then you do on-demand calculation based on what the client needs to do. And in the beginning, it was a really quite small project, so it needed to be done cheap. We needed to do a lot with small resources, both in development resources, but also in hardware. And it was a Python shop, so we had Django and things like that. So with those things and the fact that I was supposed to both operate it and develop it, we wanted something that was distributed, so it didn't go down, so we could focus on developing, and it needed to scale as we grew bigger. So then enter Erlang. So once we saw that Python and Postgres and things like that wasn't really enough for us, we just needed something different. And I first came across with Erlang when we looked at React. And once you looked at it, and not just the database, but also like the ins and outs and the concepts of how they chose to solve things, I was really, really inspired. So we started looking at doing some protocol things. It's like you just fell in love, or you don't know if you have like a crush. So you start like filling, and yeah, you're a bit curious. It doesn't really work. You know, you want to, they don't want to, or they want, yeah. So it's a bit trembling, right? But then as the mindset set in, the pivot came, right? So then you're head over heels in love, like, oh yeah, let's rewrite the whole thing in Erlang. How hard can it be? We just done this for like 4 years. Yeah, and I think that is, for me as a developer, that's something that is, once you see something and you fall in love in the design patterns and the things, and it all feels so, oh, it's so comfy, right? Yeah, but then the honeymoon is over, right? So then comes the steady state, and like, yeah, okay. well, so it is really good, and at some point it's really awesome. But maybe we shouldn't rewrite everything, because Python is still really good at many things, and also we have like a few thousand lines of code, which is not like this huge pile of mud. It's actually modular and quite well working. So then it's set, like, okay, so we're going to have both, because Erlang is too good to not have in some parts, but Python is also really, really powerful in other places. So there it's set, like, okay, so we're going to have both languages. So what we did then is we looked at examples that exist. So at the previous talk was about this C node thing. So I mean, there are several examples of how you can interact with another program from Erlang, and that's what we did. So we wrote like a wrapper application actually in Erlang, which then could spawn processes, Python processes, and that process was then a Python module that we wrote. And we hijacked standard in and standard out, and we built like a really, really simple protocol, and we sent Erlang term format objects back and forth. And that actually worked quite well. It's running right now, and we're happy with it. One of the biggest issues for me is the double code. So you need to do things in Erlang, setting up like the framework or the interface, right? And then you need to call into Python, and then you write the code, both the wrapping code, where you need to take p-lists or dicts or whatever and convert it, and then have the code. So you need to be in several places, even though you just want to do one thing. So this is a simplified view of a part of Infranet, and this is the running state. So you can forget about like the initial thing and how you get it up and running. But basically, so we have a data generator. If we talk about key value stores, we can say like we're generating keys, and then we want to fetch those and do something with it. That's what's in data fetch. And then when we look at data, we might find that we're interested in more data. So then we need to have a feedback loop back into the data generator so it can go out again. And then once we fetch data, we want to fold it and do something with it and present it to a client, right? And the P port here is actually faking that it does it. So from data gen and data fold processes view, they think that the data port module or P port module is the one that does it, where in fact it actually sends out via standard in and out to a Python process, which executes it and then reports it. The reason why we did this is when you do that, Python is sequential. So as it starts crunching, you're not going to be able to talk to it. So we made this one asynchronous. So once it calls Erlang port, it can still take calls. So you can ask it how it does and how it performs, but you can't really do anything because it's blocked. Or the Python side is blocked anyway. So you can't get any real work done once it's processing. So we wanted more. And with all these, we felt that there was a lot of things we did here which was really similar, both for ourselves, but also it felt like if you want to do this in another application, that would actually be quite easy to generalize this and just remove some names that are proprietary for us and make a structure that is general. So actually, I don't remember when it was, but I was speaking then to Martin at Erlang Solutions, and I presented the idea. And they had similar things going on where they wanted to connect the communities. So we started brainstorming around it, and I got to show the code that I've done and the ideas of where we wanted to go. And with the help of Dima, then we actually rewrote it to become something more close and something more general purpose. And it's taking some time, because we have had other things to do, but it's actually closing in now. So we are actually just about to take some parts of the Pyrlang thing into production, and then we're going to go forward from that. So what is Pyrlang? Well, first of all, the name is pending because it's not a new language, which can be misleading. So mainly it's a Python package, and what that Python package does is it's incorporating the distributed Erlang communication, so it actually can connect to EPMD and act as if it is a node. In Erlang, it's a small footprint. It doesn't even have to be a footprint if you don't want to. We think that that's going to be the thing that helps you come forward, but in essence, since it looks like a node, you can actually access it without anything in Erlang. There are no shortcuts when it comes to learning, so since this is not a new language, it's not going to like help your fake Erlang to being Python or fake Python in being Erlang. You need to know the language, you need to know the benefits you're going to get from the library that you're choosing or whatever you want to do. Hopefully with this, you're going to get the best of both worlds. So you're using Python where Python works well, and you're using Erlang where Erlang works well. And, well, the shortcut might be the fact that hopefully we lessen the glue code. So you're up and running more quick, and you don't need to do all these things around it. I just got a strange error message. I'm just going to move that. So the same example here now with Pyrlang. And although what you would need to do is you would need to add a small wrapper around the data fetch clause, if it's like that, which makes it fake and look like a process. And with that, you can remove these double-sided code, because you can actually call from DataGen. When you initialize this, you just point at this process saying like, yeah, you can push data to that one, or you could even initiate this one saying you fetch data from Erl node 1 at, and then an IP address or whatever, and it's actually going to fetch it when it wants to, and it can push data back whenever it wants to, and it can push data to fold whenever it wants to. So we both remove the duplication of code, the fact that you need to do things in multiple places at the same time, and also we open up for a more asynchronous message passing, which is then one of the things that Erlang is really, really good at, and we now can get that more into the flow of Python. So with Pyrlang, we're trying then to implement the generic patterns of Erlang, and then I haven't wrote that, but also OTPs or Gensor and things like that. So we have a class in Python that acts and look like a process, and it can take calls like a process. And then we want to implement the timeouts. So when you do calls, you get timeouts as you do in Erlang. We want to implement and have the fact that you can have monitoring and links, and that works both ways. So if you, instead of needing to have like a try catch all in Python, which send like back I failed, you can start a process which is a class, and if that has an exception, they're actually going to by automatically, if you have a link, be sent back to the Erlang process that are monitoring or linked to this class. So you get all this error handling for free once we get these essentials going. And then we have call and cast. As I said, you can do both synchronous and asynchronous message passing. And so really the goal is that you should be able to call really easy. In Erlang, we have RPC calls, right? So you have the node, then you have the model, the function, the argument, which is a quite common pattern which you use a lot in Erlang. You can do that in Python, but it doesn't really match as well as in Python. You have more the fact that everything is an object. Even functions are objects. They just have a call attribute on them. So and you have also arguments and keyword arguments. So, and here where you have the small footprint in Erlang, that we have actually implemented a notebook-like module, which is called Py, and then you have call, and you put the node, which is then a Python node. You have an object path, and then you send arguments or keyword arguments to it. And that works really well if you want to access some built-in. But what if you want to start having classes and things like that within Python? That's a really nasty thing to send back, because it's not really easy to make that into types of types of Erlang, and also if you have like a class or something like that in Python, you probably don't want the class, you want the reference to it. So with that, we can have also the fact that you can create like a context on a node, which you can refer to several times. So when you make a call like this, you get something back, which is just a reference of an object that exists within that node. And you can refer to that in arguments and keyword arguments on later calls. And with that, once you get there, and we're not really there yet, but it works kind of-ish, it becomes quite clean. And you can actually see as you're in Erlang, you can actually see that you're making calls which looks quite similar to Python code, even though it's still in Erlang syntax. And I got a bit nervous when I looked at my own abstract yesterday, and I was like, oh shit, I'm not speaking about the things I said I was going to speak. Which is always a bad thing, but it's better to be honest. Future libs. One of the things that I'm almost most interested in is the VSGI server, because if you were able to run Cowboy as the front end and then just falling back to a Django application, being able to hijack calls in real time with Redbug, just fetching people's IP addresses, that's things that we don't have in Python. We can like restart a node and then have a debug if IP address, then you restart everything and you maybe get something out. Would be a huge leap forward. Also looking at, for example, TensorFlow, which is a really cool library. When you start looking at the distribution, it's not as neat. You can't quote me on that because I haven't worked on it that much. I've just looked a little bit, and it might have changed since I looked. But anyway, Erlang is really, really, really good at distribution. So there's no point, or there's no reason for me anyway to think that it wouldn't do that really, really well. So these are the two things I'm really hoping to see in the future. But before that, we have some battles on the horizon. So types, binaries, strings, Unicode, those are all awesome things. They are almost as evil as time. Maybe not, but close enough, right? So this transition was harder than we thought, because when we made this idea, we were on Python 2.7, which is much more allowing when it comes to string or Unicode. So it's not as picky on you. When you go to Python 3, they bad. It needs to be Unicode when it says it should be Unicode, even though it's bytes and everything. ASCII, it doesn't matter. If it's Unicode, it's Unicode. And we don't have that in Erlang. We have representation. We can do things like that, but we don't have the type. So we have issues right now when we're trying to run it. In the round trip, you send something, and you maybe get a string, you maybe get a list. And then when you get back, it might be a string, or it might be a list, or it's a Unicode object, or a binary, or yeah. So we tried to fix the faults, and then we fix it at one end, but we break something at the other end. So that one is one of the bigger things. We're probably going to look at that with inline calls or something, so you can like force or tell the parser of Pyrlang how you should interpret parts. It's not as clean, but it's a thing. I tried to talk to Kenneth, and he's like, "Oh yeah, Unicode object. We can fix that in an hour. Just nobody has ever asked." Like, no, but really, so it's a hard thing. But we're going to look at it, and I think even going forward, looking at other languages, Unicode are native objects in many languages, so it would be a nice thing to try and get something. I think we would benefit a lot if we could in some way, especially when extracting data, like say like this is Unicode. And then we have P-node startup. We have asynchronous, so when something executes, EPMD doesn't get, if you have bad code, if something blocks for a long time, EPMD communication will be down for that time. So we're looking into how to do that, if we should enforce asynchronous, or if we should have maybe two threads. So one thread running the EPMD code, and then one thread running the actual process or program. And they are not there yet, but I'm going to make all these issues on the web page. Or the GitHub, We don't have a page yet, but GitHub Pyrlang, because it's much easier. If we can't get other feedback from others, it's going to be implemented in a way which suits us. But as we're laying down a general framework, it's much better to have more ideas coming in, so you can make a generic solution for the problem. Yeah, and that was what I had. Thank you.
Questions? How tolerant is Pyrlang? I mean, like, do you have any external dependencies? Like, do you use any servers, or do you just use what Python standard lib has?
So I don't remember. It doesn't have a lot of dependency. If you want it to perform, you need to have Rust locally, and we're going to look at building libraries. So we implemented for performance. So the term, like how you go back and forth between Erlang term format is implemented in Rust, because that becomes extremely much more performant.
Is that on Erlang side or on Python?
No, that's on the Python side.
Okay.
It is optional, but it doesn't perform. So you can get up and running without. But if you want to do it in production environment and start using it for real, we highly recommend that you use the native one. We had Givent before, but since it's taken so long, and async.io actually is quite performant now, so we're going to re-implement and just using that one as the engine. And then I think actually it is the basic Python only.
So you're basically going to only support the latest Python 3 version?
Well, it's 3.5, I think, isn't it? Yeah, 3.5.
Oh.
Pardon? Yeah, Python 2 is, yeah, well, in 6 months anyway.
It's not the case for us. So.
Yeah.
Just out of curiosity, have you tried to run 2 Python or Pyrlang nodes face-to-face without Erlang?
Yeah, we've done it actually. It worked.
Oh.
Yeah. I'm not going to do it here, though.
Okay. If there's no more questions, then let's thank again the speaker. And
thank you.